cost of developing geothermal power begins with the exploration phase, where you're exploring to see, is this a thermal anomaly that looks promising, of high enough quality. Then you use geophysics and geology and geochemistry to search for such areas, and then you drill a geothermal well. Now, geothermal wells cost around about $5 million each, and you need to drill several of them to get resource assurance that you have enough resource to drill. And then, having done that assessment, and you need to get a power purchase agreement. Once you've got the power purchase agreement, you can go ahead to buy turbines and start constructing a power plant, and also drilling the production and injection wells that you need to operate the geothermal system. Because we not only produce the water and steam to the surface, but re-inject all the material, all the fluid, so it doesn't get onto the landscape and become an environmental problem. So we are, overall, it's estimated that the exploration and drilling and reservoir assessment phase of a geothermal development is about 30% of the total cost. And then you've got about 60% in the capital cost and amortization of the investment for the power plant, and then about 10% in operation and maintenance. So the answer to your question briefly is about a third.
So if you can get 10 times as much power, another way to say that would be you would cut 90% of the cost of the wells.
Well, you'd cut the 30% down to less than 10%, the 30% of the wells.
Okay.
But there are other issues, and that is the number of wells you need are fewer. If you get 10 times the power output per well, instead of 10 wells, you need 1. And that means the environmental footprint that you have in developing a geothermal field is less. The other issue about the power plant is that using much higher energy fluid or more higher enthalpy fluid is that the efficiency of power generation in the turbine is also increased. So you may have less capital cost in building the power plant.